will be able to obtain calcium oxide and the carbon monoxide obtained from the welcome to this video. In our previous video, we were able to study the extraction of toner. That is, we obtain sodium carbonate from toner, which is a double salt. In this video, we are going to look at extraction of sodium carbonate through the Solvay process. So, for the Solvay process, it requires the raw materials. It requires the raw materials. And the raw materials for this process are, we have ammonia, gas, followed by coke, and finally calcium carbonate, and also sodium chloride. These are the raw materials for the Solvay process. So you find that in the Solvay process, we have several steps. For example, the first step of the Solvay process, we have the chamber, which is referred to as the first absorption tower, which mostly, this one is the first absorption tower, which is usually referred to as the Solvay tower. This one is the Solvay tower. So in this tower, we are going to have ammonia from the ammonia source. So here we have ammonia source. Ammonia source. So the ammonia from this source is going to be pumped into the first absorption tower, where it will react with brine. So it will react with brine to form ammoniated brine, or we can call it ammoniacal brine. Then the ammoniacal brine from this chamber will be pumped to the carbonator. This one, we have the carbonator here. So this one is the carbonator. In the carbonator, this ammoniacal brine will trickle down the carbonator, whereas carbon dioxide that is obtained from the kiln, will enter the carbonator from below. That is now carbon dioxide. So the carbon dioxide in the kiln is produced from the decomposition of limestone, which is calcium carbonate, or the combustion of coke. So the equation at the kiln will be, calcium carbonate. We heat, we will be able to obtain calcium oxide and carbon dioxide gas. So the carbon dioxide obtained from the kiln is then pumped to the carbonator, where it will react with the ammoniacal brine. We will obtain sodium hydrogen carbonate and ammonium chloride. So from the carbonator, the mixture is then pumped to the filter. So here we'll be having the filter. The equation at the carbonator. Will be, we have ammonia gas with carbon dioxide with sodium chloride with water. We will be able to have ammonium chloride, which is aqueous, plus sodium hydrogen carbonate, which is a solid. So this equation, you find that it is balanced, whereby nitrogen 1, 1, hydrogen is 3, 5. This one is 4 plus 1, 5. Carbon is 1. Here we have 1. Oxygen is 2 plus 1, 3. This is 3. Sodium 1, 1. Chloride is 1 and also 1. So here, this is the equation at the carbonator. So the products from the carbonator will now be pumped to the filter, whereby we will obtain ammonium chloride as the filtrate, and sodium hydrogen carbonate as our residue. The residue is then pumped to the next chamber, which is referred to as the roaster. So here we will be having the roaster. In the roaster, the sodium hydrogen carbonate will be decomposed for us to obtain sodium carbonate, carbon 4 oxide, and water as the only product. So the equation at the roaster, will be sodium hydrogen carbonate solid. You heat, we will obtain sodium carbonate solid plus carbon 4 oxide plus this is carbon 4 oxide plus water, liquid then gas. Here we balance this one, so we put 2 here. So the equation that will lead to production of sodium carbonate is that one. So our product will be sodium carbonate. Now you notice that our products, we have water and carbon 4 oxide. So the carbon 4 oxide from the roaster is pumped back to the carbonator. So here carbon 4 oxide is pumped back to the carbonator. You find that the other product is water. So water from the roaster is then mixed with calcium oxide from the kiln. So here we will be having calcium oxide. So this is water and this is calcium oxide. So calcium oxide will be slaked with water. So here a process which is referred to as slaking for us to obtain calcium oxide, which is pumped to the chamber which is referred to as ammonia generator. So this one is the ammonia generator. Ammonia generator. In the ammonia generator, the filtrate from the filter, which is ammonium chloride, will react with the slaked calcium oxide, which is calcium hydroxide. So the equation for slaking will be, that is the equation for slaking. Slaking equation. We will have calcium oxide solid plus water from the roaster liquid. We will be able to obtain calcium hydroxide. So to balance this one, this is 2. Yeah, it is balanced the way it is. So this calcium oxide that has been as a product from slaking is pumped to the ammonia generator. So this one is calcium hydroxide and our filtrate, which is ammonium chloride. So ammonium chloride and calcium hydroxide will react to give us our byproduct for this Solvay process, which is referred to as calcium chloride. So the equation at the ammonia generator, equation at ammonia generator will be, we have calcium hydroxide plus, this is aqueous, plus ammonium chloride aqueous. We will be able to obtain the byproduct, which is calcium chloride and water with ammonia. With ammonia. So to balance that one, we put 2 there. We put 2 here. And which other place? Hydrogen is 2 plus 8. It is 10. Here is 6 plus, we put 2 there. So hydrogen is balanced. So the equation will be balanced. Now, our byproduct here is calcium chloride, which has a variety of uses. For instance, anhydrous calcium chloride is used as a drying agent. Now, the water produced here is moved back to the system. That it means that it is recycled in this process. whereas ammonia here is also recycled, whereby we'll have ammonia from this ammonia generator. Ammonia moves back here, so this is ammonia gas being recycled, whereas our byproduct here for our case will be calcium chloride. So you find that the Solvay process is the most efficient industrial process, in that most of the waste products are recycled back in the process. For instance, carbon dioxide and water. You find that carbon dioxide and water are recycled in this process, thereby minimizing the cost of production. The Solvay process plant is usually situated in an area that has got a source of a water body. For instance, it can be located near a large water body or a river. Reason being, you find that the carbonator, the reaction in the carbonator produces a lot of heat, and this carbonator requires constant cooling. So the reason why we put it near a river is for us to obtain water that can be used to cool the carbonator. We have a variety of uses of this sodium carbonate. Sodium carbonate is used in the paper industry. It is used in glass making. Thank you for watching this video. Please like, subscribe and share. In case of anything, you can comment below there.